Hey guys, this is Coach Lowe, and we are going to be talking a little bit today about proving that lines are parallel. And this is Chapter 3, Section 5. Proving lines are parallel. Now, we have worked quite a bit with corresponding angles, consecutive or same side interior, alternate exterior. We've talked about transversals, when you have a transversal that's perpendicular to the lines that it's cutting through. And so all of these postulates have a converse. All of those things that we worked with have a converse. So we have the converse of corresponding angles that says if you have two lines that are cut by a transversal and corresponding angles are congruent, then those lines are parallel. Now, before we started out with parallel lines, now we're starting out with angles and saying that they're congruent or supplementary, which tells us the lines are parallel. So if I give you a couple of lines here, and I say, okay, you know what? I need to know if these lines are parallel. And I have no idea if they are or not. But I do have some information that's been given to me. And the information given is this angle is 47 degrees. And this angle right here is also 47 degrees. I can determine that these two lines are in fact parallel because corresponding angles, those are corresponding angles, they're in the same spot. If I pick up this group of 4 and slide it down to that group of 4, they're in the same spot and they are congruent. So because I have corresponding angles here that are congruent in measure, then I know lines L and M are in fact parallel to each other. Now we can do the same thing with alternate interior angles. So from here, if I had given you 47 here, oh, excuse me, not 47 there. Let me back that up. That is not 47. That is not alternate interior. So if I had given you this angle and this angle, alternate interior angles are also congruent, equal in measure. So I could say, hey, these two lines are parallel because I know that alternate interior angles are congruent. So because alternate interior angles are congruent, then the lines are parallel. So we're switching the if and the then in our statements that we had previously. I can also find linear pairs just like we have done before. So we need to make sure that in our notebooks, we have the first three postulates, and then we have postulate 3.4 all the way to 3.8. So you will need to make sure you have those written down in your notebook. So we have the converse of corresponding angles postulate, which we just talked about, that's 3.4. The alternate exterior angles converse, which says we know that alternate exterior angles are congruent, but it says if you have two lines, alternate exterior angles are congruent, then the lines are parallel. So that would be alternate exterior, that'd be this angle and this one right here. So if I gave you those two as 47 degrees, you could say, hey, those lines are parallel. Now, if I give you one as 47 and one as 48, then no, they're not parallel. 3.6 is consecutive interior, so same side interior. Those angles are supplementary. So if I just give you these two guys and say this is 133 degrees and these two are the only ones given, and you add those and you go, hey, that's 180 degrees. Therefore, those lines have to be parallel because I know same side interior are supplementary. That is 3.6. 3.7 is alternate interior. So again, if I gave you these 2-degree measures, 47 and 47, you'd be like, hey, those two angles are congruent. They're equal in measure. All right, then those two lines have to be parallel. And then 3.8 is perpendicular transversal, and it says if you have two lines, or if two lines are perpendicular to the same line, then they have to be parallel. So if I have two lines, and my transversal cuts through here, and we see that there are right angles on these guys, then I know that these two lines are parallel to each other. They have to be. These are corresponding angles, whether they're 90 degrees or, like this case, 47 degrees, corresponding angles are equal in measure. So this is kind of a fun one though because they're perpendicular, just kind of cool. All right, one more, and then we will talk more about this in class, but let's go ahead and draw this guy. All right, so here's what the question is. I have line PQ, so I'll go ahead and put points P and Q on here, and I have line MN, and I have a transversal WZ. These are intersecting at points X and Y. All right, so I want to find the measure of angle ZYN so that line PQ is parallel to line MN. All right, and we want to make sure that we show our work. All right, let me give you some more information. They told me that PXW is 11x minus 25, and we'll put parentheses around that with a degree sign. And so that's the degree measure. And then ZYN is 7x plus 35. All right, so let's talk about where these guys are. They are outside the parallel lines, alternating the transversal. So I know from previous work that those are alternate interior angles. Alternate interior angles are congruent in measure if the lines are parallel. We are trying to make it so that those lines are parallel. In order for these two lines to be parallel to each other, these two guys must be equal to each other. They have to be the same measure. They have to be congruent. Okay, so how do I do that? Well, I'm going to force it here. I'm going to make 11x minus 25 equal to 7x plus 35 because I want to find the value of x when those two are equal. If I can do that, that means when I plug x in here, I'll get an angle measure. I plug the same x in here, I will get the same angle measure, which will force parallel lines. All right, so let's solve this. Subtract 7x from both sides. We want to look at the sign that's in front of the number and do the opposite. So 4x minus 25 equals 35, and then I'll add 25 to both sides. So 4x equals 60, or x is 60 divided by 4, which is 15. So when x is 15, remember what I wanted. I want the measure of x, y, n. So when x is 15, 7 times 15 plus 35. 7 times 15. So 35, 7 times 1 is 7. So there's 105 plus 35. That makes 140 degrees. So the measure of ZYN is 140 degrees. I'm just going to double check this, all right? 11 times 15, 10 times 15 is 150 plus 15, 165. So 165 minus 25 is 140. Yay. All right. So they are both the same measure. So alternate interior angles are the same measure when my lines are parallel. So we have just forced those lines to be parallel. Now, if you choose any other number for x besides 15, so if you do it any other way, besides setting those equal, you can plug in a number for x, but those two angle measures will not be the same. So if I plug in 2, I'm not going to get the exact same angle measure for both of these, only when x is 15. All right, we'll try out some proofs and we'll talk about these postulates when we're back in class, but I'm looking forward to seeing you guys and working through some of these problems. Make sure that you know these postulates and that you have all of them in your notebook. All right, guys, this is Coach Lowe, and I'm out.